All right, so in this screencast, I wanted to take number 3 and first solve it geometrically. And so let's get started. We're talking about a mass that's hanging from 2 ropes. This side, it's a little hard to see in the diagram, but this side is a 40-degree angle, and this side is a 20-degree angle. And the mass of our object is 50 kilograms. So a force diagram for this situation looks like the weight going down, W, and we can calculate that right now. Weight is going to be 50 kilograms times 10 newtons per 1 kilogram. This is because we're on the Earth's surface. So that's going to give us 500 newtons of weight. So that's our weight right there. Then we have a rope that's going at an angle to the left, and this angle looks like it's 40 degrees. And then we have another rope at an angle to the right, looks like it's about 20 degrees. Okay? And right away I might as well figure out, okay, so 90 degrees minus 20 degrees will give me 50 degrees. So this angle is 50 degrees. And on this side, 90 degrees minus 40 degrees. This is wrong. Hold on a second. Sorry about that. Okay, try that one again. 90 degrees minus 20 degrees is going to be 70 degrees. That's this angle. And the other angle will be 90 degrees minus 40 degrees. And that's going to be 50 degrees. So this angle here is 50 degrees. Okay? So, fundamental logic, since our acceleration is 0, in other words, we're not changing velocity here, that means our forces need to add up to 0. Okay? So if I take all these forces, I might as well name this one T1 and this one T2. So if I take all my forces, I take T1, this is a force that has magnitude and direction. I take T2, another force with magnitude and direction, and I add to it my weight that is magnitude and direction. These must add to 0. Okay? Whoops. Let's make this look nice. Move this over just a little bit. There we go. That looks pretty cool. Now, let's see here. I can show this geometrically. So this statement here means this vector, I'm going to make it a little longer so that it's bigger. You can see it easier. So there's my T2, all right? I will add to that my T1. Okay. And I'm going to add the vectors. Looks like I made them about correct in length. So I know that because T2 plus T1 plus my weight, which is straight down, there's my weight, these vectors must add to 0. Okay? So I've shown it to be true geometrically. Now we're going to need to figure out these angles in order to solve the problem. Okay? So I need some reference lines. And it looks like from the vertical to my T1, so this angle here is 50, therefore this angle here is 50, which means that that angle there is 50, okay? And if I look at the other side, my T2 sweeps with the vertical to make a 70-degree angle. Okay, that means this side's 70 degrees. And now 70 plus 50 will give me 120. So I should, if I subtract 120 from 180, I'll get my missing side. Is that right? No, that's 60. Sorry. There we go. So this is a 50, 60, 70 degree triangle, and it's not a right triangle. So since this is not a right triangle, then I'm going to need to use my law of sines. So let's set it up. Sine of 70 degrees over T1 has to equal my sine of 60 degrees over, now that's my weight, which is 500 newtons, and that has to equal sine of 50 degrees over my T2. All right? So I'll just take half of this and solve for T1 first. So T1 sine 60 has to equal 500 newtons sine 70. So T1 has to equal 500 newtons scaled by sine 70 over sine 60. Okay? So using a calculator now, okay, let's do sine 70. No, I'll do the denominator first. Get the denominator out of the way. 60 degrees, take the sine of that, gives me a decimal. Then I'll do 1 over that, and I'll add that to memory. And now I'll do the numerator. I'll take 70 degrees and do the sine of that times 500. And this gives me 469, but I'll need to multiply by the stuff I had in memory. And that gives me 543, roughly. So this is telling me that T1 looks like it's about 543 newtons. And we can do the same thing in order to find T2. I'll just use this half. Okay. So T2 sine 60 degrees has to equal 500 newtons times sine 50 degrees. Okay. And this means that T2 is equal to 500 newtons sine 50 degrees over sine 60 degrees. Okay, we use a calculator to figure that out. Okay, let's clear everything. And now I will do the denominator first. 60 degrees sine 1 over that. Add it to memory. Okay, Then I'll do the numerator, 50, take the sign, times 500 equals, and then I'll multiply what I've got in memory, and that's 442 newtons. So looks like T2 should be about 442 newtons. So let's try to make sense of this now. If I scroll up, oh, not that far. So T2, it looks like T2 is 442 newtons. My weight is 500 newtons. And my T1 is going to be 543 newtons. All right. So that was a geometric method for solving number 3. Next, I'm going to show you a different method where we break up each of the forces into components. And it's a little more complicated, a little more work. Anyway, thanks for watching. Have a good day.